So let's do another example problem. Let's say that we have a person driving along, okay, and they're in a tunnel or something, and there's a great big truck stopped in front of them, okay, and so this is stopped, so the velocity is 0. The car is driving with a velocity of 25 meters per second, and the driver sounds a horn. Okay, so the horn, let's say that the initial frequency of the horn is 1200 hertz. So the sound waves are Doppler shifted because the car is moving. They reflect off of the stopped vehicle and come back. And now the driver hears the horn sound plus the reflected sound, and they hear a beat frequency. And so the question is, what is the beat frequency that this driver hears? Okay, so in order to do that, we need to know what sound the driver hears. Okay, so first of all, you need to know the speed of sound. Let's say it's kind of a little bit cooler day, so 340 meters per second is the speed of sound. Okay, so what we've got is we've got the car driving along, we got the truck. So the question is, what is the frequency at the truck? Okay, well, the frequency that's bouncing off the truck, because the car is moving, the truck is not moving, so it's going to be 1 minus the velocity of the car over the speed times f naught. Okay, so that is the frequency at the truck. Now that's the frequency that's coming back. So what frequency does this person over here hear? We'll make that f double prime. So f double prime is, now they're the one that's hearing, okay, and so now the detector is moving, okay, so the detector is moving, so the source is not moving, and so the detector is moving, and so that's going to be heading towards the source of the sound, so that's going to be 1 v over c times the sound that was coming towards them, f prime. Well, if I put all that together, the sound that's heard is going to be 1 plus v over c divided by 1 minus v over c times f naught. So the sound that's heard is going to be equal to 1 plus 25 meters per second over 340 meters per second divided by 1 minus 25 meters per second over 340 meters per second times 1200 hertz. And so the sound that they hear is going to be 1390 hertz. Okay, so what is the beat frequency? Well, the beat frequency is going to be the difference between the 1390 hertz and the initial 1200 hertz, because the beat frequency is the difference in the two. So the beat frequency will be 190 hertz. Okay. All right. So that's the sound that they hear. And so I know a lot of people do that. They actually drive into a tunnel or a parking garage and they hit the horn just because it sounds kind of like different when it's under those circumstances. So anyway, that is another example of the Doppler effect.